All right, ladies and gentlemen, we're going to be working on our second change in the structure of the atom. That should be available to you in ionization notes in practice. So let's jump over there now. I'm going to switch to my camera so I can annotate some notes for you. Ionization is the second change in the atom. This is where electrons change. So if you gain or lose electrons, that happens through a process called ionization. So ionization is defined as a process where electrons are gained or lost. They do this to become stable. When electrons are gained or lost, that happens to create charges. Okay? That happens to create charges. As far as how each element will ionize depends very heavily on whether it is a metal or a nonmetal. Okay? So metals will always lose electrons, and nonmetals will always gain electrons. That means that metals are always going to be positively charged, and nonmetals are always going to be negatively charged. Just a quick review before we jump too deep into the details of the new material. Let's review our periodic table setup. Remember that we have our staircase that goes down from group 13 to group 18 diagonally. That's called the metalloid staircase, and that separates the metals on the left from the non-metals on the right. Again, we have the metalloid staircase that puts the metals on the left and the non-metals to the right. The only exception to that rule is up here we have hydrogen at the very top of group 1, and that is a non-metal. Metals are going to lose electrons, and since what we are losing happens to be a negatively charged particle, it'll result in a positive overall charge. Metals lose electrons and have positive overall charges. Nonmetals are going to gain electrons, and again, since we're gaining something that is negative, we end up with an overall negative charge for the atom. If we focus on metals, metals are going to lose electrons. When they lose electrons, they're going to end up with positive charges. We call the elements that have with positive charges, we call those cations. And if you ever forget which one is a positive or a negative, think about what the T in cation looks like. It looks like a positive charge. So those ones that have positive charges are cations. Okay? Now, on the flip side of that, nonmetals gain electrons. They end up with a negative overall charge, and we refer to those negatively charged ions as anions. Now, we're going to learn in our bonding chapter, our bonding unit, how metals and nonmetals actually work together to make ions. Metals need to lose, nonmetals need to gain. The metal will give its electrons to the nonmetal, and then they'll both be happy. They work together, they scratch each other's back, so to speak. Now, if we look down below, this is the primary focus of today. Can we go from ion symbols, which are the element symbols with their charges, or can we go from our nuclear symbols, symbol, charge, mass number, atomic number, symbol, charge, mass number, atomic number. Can we go from those two options to figure out the number of protons, neutrons, and electrons that are in these ionized atoms? That is our primary focus for today. Let's start with magnesium. The ion symbol for magnesium is Mg, which is the symbol from our periodic table. Right here is magnesium. And it's telling us that it has a +2 charge. That means that 2 electrons were lost. Okay? 2 electrons were lost. That gives us the +2 charge. The oxygen over here has a -2. That means that 2 electrons were gained. Symbol-wise, you might think that positives would mean gaining and negatives would mean losing. Ionization is backwards. It's backwards. Remember that. Charges are backwards for electrons. Positive charge, electron lost. Negative charge, electron gained. My approach to this would be to take our ion symbol and make it into a nuclear symbol. And what I mean by that is I think it benefits us to have all of our information we need in one place. We know what the element is, so we know the atomic number of 12. We can find that from the periodic table right here. Atomic number is 12 for magnesium, mass is 24. Okay, so mass number 24, atomic number 12. We know it's Mg, and we know it has a +2 charge from the ion symbol. Now, atomic number then is 12, mass number is 24. That means we have 12 protons. That also means mass number minus atomic number, 24 minus 12 is 12 neutrons. If the atom was neutral, so the original neutral number of electrons before they were gained or lost would be the same as the protons. That's what we talked about in the past chapters. Right? Protons and electrons are equal in the original atom that is neutral. But the +2 charge means that 2 electrons were lost. So from the neutral number, I need to take 2 away, and I end up with 10 electrons. So from magnesium 2412 with a +2 charge, we use the atomic number to find the protons. We take the mass number minus the atomic number to find neutrons. We take the number of protons, +2 means we lost 2. Protons minus 2 is 10 electrons. So if I were to ask you how many protons, neutrons, and electrons are in a magnesium +2 ion, you would use the atomic number to find 12 protons, mass number minus atomic number to find 12 neutrons, and then you can either take the neutral number of electrons minus the 2, because it has a +2 charge, minus the 2 to get 10 electrons, or you can look at it this way. 12 protons and 12 electrons would be neutral. It has a +2, so I need to take 2 electrons away. 12 minus 2 either way gives us 10 electrons. Now, let's head in the opposite direction. Let's look at a nonmetal. A nonmetal with a -2 charge, with a mass number of 16 and an atomic number of 8. Atomic number of 8 gives me 8 protons. Check. 16 minus 8, mass number minus atomic number, gives me 8 neutrons. If this was neutral, we would have 8 electrons as well. But it has a -2 charge. Remember that the -2 means 2 electrons were gained. Okay? If we gain 2 electrons, we go from 8 plus 2 is 10. Remember, ionization is backwards. Okay, it's backwards. Positive charges mean electrons lost. Negative means electrons gained. All right? Now remember, you can always go back and re-watch this, or go back if there's something that you missed. Chromium with a +4 charge. That's the ion symbol. Let's add the mass number and atomic number from the periodic table. Chromium's right here. Mass of 52, atomic number of 24. Let's put that in, just so we have all of our data together in one spot. That's going to help me figure out that I have 24 protons. 52 minus 24 gives me 28 neutrons. Mass number minus atomic number gives you neutrons. And then +4. That means I have 4 more protons than electrons. If I have 24 protons, I must have 4 less than that, 20 electrons. Now, because of where chromium is on the periodic table, you'll see at times Roman numerals
added in to names. Okay? So anything that is in group 1 of the periodic table, in group 2 of the periodic table, these guys, this whole column here, are always +1. Okay, they're always +1. This whole group here is always +2. From there over to the staircase, they can have multiple charges. So we have to put a Roman numeral in. Chromium can be +2, +4, or +6. So how do we know which one it is? Well, whatever the charge is, chromium +4, we would put the Roman numeral 4 after. If it was chromium 2, we would put chromium Roman number 2. Okay? Now, there are 5 atoms over here: silver, cadmium, zinc, aluminum, and boron, that have set charges as well. So everything in group 1 or 2, and then silver, cadmium, zinc, aluminum, and boron. Silver is your +1 all the time. Cadmium and zinc, one group higher, +2 and +2. Boron and aluminum, another group higher, +3 all the time, +3. So silver's a 1, a little bit higher, zinc and cadmium 2, boron and aluminum a little bit higher, 3. 1, 2, 2, 3, 3. And then anything else between group 2 and the staircase that does not have an orange bar needs a Roman numeral. Okay. Now, here's the other thing I want you to be able to do. I want you to be able to go from the numbers of particles to the ion symbol and or the nuclear symbol. So how do we know that this one's 10? Well, the number of protons identifies what the element is. So if we know protons are 50, we know the atomic number is 50. We can look up 50 on the table. Right here, 50 is 10 with SN as its symbol. So we put down SN. We look at 50 and 46. There's 4 more positive protons than electrons. 4 more positive than negative. So we get a +4 charge. Okay? And then if you were asked to do the ion symbol, that's all you would need to show. SN, we know it's 10 with a +4 charge because there's 4 more protons than electrons. If I asked you for the mass number, you would just add those in. Mass and atomic number for a nuclear symbol. For this one, protons are 17. Chlorine is number 17. Put Cl, 17 protons, 18 electrons. There's an extra electron, 1 more negative than positive, so we get a net charge of -1. If I asked you for the ion symbol, that's all you'd have to show me. If I asked you for the nuclear symbol, I'd like you to go through and add in your mass number and your atomic number. What I'd like you to do now is go through the first half of the other sheet that's attached to this page in the module. And I want you to do the first 5 rows. Okay, the first 5 rows, see if you can use what we talked about in our notes to complete that.